Hello everyone, how are you? I hope you all are doing great at your end and you all have watched all the videos updated till now. If not, please go and check it. Each video has given you the exam tips that you need to focus so that you avoid those small mistakes which actually pull down from the marks. The exam trap, the question traps, what is the examiner looking forward for you in the notebook? Each and every video unlock those small tricks and tactics that is going to be worth it, I hope, for sure for you during your examination. Do watch it and let me know if you actually feel like that they are worth it and they are actually worth going out. And as I always say, for any questions and any queries, you are most welcome to drop out the questions in the drop box or the comment box. Yeah. So now today it's the time for free radical mechanism. Now, before we deep dive into this free radical mechanism, there are two types of cleavages. One is homolytic cleavage and one is heterolytic cleavage. The word homo means same and lytic means fission, which means that when a bond is being breaked out, the atoms acquire same number, even number of electrons. That is, each atom will gain one electron each. For example, you have an H2 molecule which breaks away, so both the hydrogen will take one electron each, and these are then called as free radicals. Now, you might be thinking that hydrogen was actually giving its electron to make a bond and now it is going away. So while you are giving a new name as a free radical, why don't you call it as a normal atom? Now, let me tell you why you don't call it as a normal atom. Because over here, when you are breaking a bond, we know that bond breaking is an endothermic process. So when you are breaking the bond, these electrons which were involved in bond formation has gained those energy. So that's why we are showing this electron with a dot separately. And this high energy makes these free radicals very reactive. Now, because free radical mechanism happens in like alkanes are already unreactive. You need someone that could make them reactive. The free radicals are the one that will make them reactive, right? Now, in what type of compounds you can observe and you can find out homolytic fission? Anything that has high temperature like UV light that can lead to a homolytic fission and it undergoes between like non-polar compounds. Now that doesn't mean that polar cannot undergo homolytic fission. Yes, under high temperatures, polar can also undergo homolytic cleavage, right? But for our syllabus, it is just like for halogens we will study about that will lead to the formation of free radicals. Next type of cleavage is heterolytic cleavage. As the word itself suggests, hetero means different, lytic means fission. So you are breaking now differently. Now when you break differently, either of the one atom is going to gain both the electrons. Now when they will gain both the electrons, the final products will be ions. One will be a cation that has given and the one that has taken both will become an anion. So homolytic fission is leading to the formation of free radicals. Heterolytic fission is leading to the formation of ions. So what we will say, one atom will gain both the electrons each, thus forming ions. Over there we will say each atom will gain one electron each, forming free radicals. Correct? Now, another point to keep in mind, when you show a movement of a single electron, show this fish arrow, which is a single-headed arrow. When you have to show a pair electron movement, like in a case of heterolytic cleavage, use a double-sided arrow, right? Next. Now, alkane has to get converted to halogenoalkane. So what all halogenoalkanes we will be making in our syllabus? It is either chloroalkanes or bromoalkanes, right? Iodine will not undergo a reaction because iodine is having a less reactivity. We know that down the group reactivity is increasing, and fluorine being become very reactive. If you will And fluorine being highly reactive, if you will undergo a reaction also, it will affect your strength of the alkyl chain. So we go for chlorine and bromine. So it happens in 3 steps: initiation, propagation, followed by termination. So in the case of initiation, you have that halide ion, let's say chlorine for this case. Both will gain one electron each. Under the presence of UV light will form chlorine-free radicals. So please mention, you write down UV light on the arrow. Forming to the propagation step, now the alkane, let's say we have taken a propane, when hit with a chlorine-free radical, will form C3H7 free radical and HCl, or there is a possibility this alkane free radical reacts with chlorine molecule to form chlorine free radical and a chloropropane, right? In the case of propagation, it's mandate that we show both the reactions in which we are forming an alkane free radical and in which we are forming chlorine free radical as well, right? Then finally the termination. What is the termination? Because the reaction will keep on going until and unless you have the presence of free radicals in your reaction mixture. So when these radicals will be over, reaction will finish. So what will happen in the termination? Two radicals can combine. Now, what are the possibilities of radicals to combine? Chlorine can combine to form Cl2. Chlorine with alkane free radical can combine to form haloalkane, or both alkane free radical can combine to form a bigger haloalkane, bigger alkane. Bigger alkane, correct? So in termination, all 3 reactions are important and compulsory. You have to write it down. Okay. Now, if you see over here, in the initiation, what we were doing, we were having a covalent bond dissociating to form free radicals. In the termination, it is the opposite of free radical formation. It's a recombination of radicals where radicals are combining, leading to the formation of covalent bond, right? In the third step, where you are getting a more amount of carbon, this step is basically called as step of carbon, but not included in our content. We don't use this particular word. But step of carbon is basically you have, let's say, 3 carbon in the reactants, but now in the products you are getting 4 reactants. So whenever the carbon increases in the chain, that's a step up, right? Now, first thing, the way of question that can come in the examination is they can directly ask you the halogenoalkane reaction. Either they can ask you in steps, like in portions, like only the propagation, only the termination or something, or only the initiation, or they can ask you the entire. The second thing that comes into contact or relevance over here is chlorofluorocarbon leads to the formation of chlorine-free radical, but not fluorine-free radical. So what we will say in these particular question, that fluorine has highest electronegative element. Also, the chlorine-fluorine bond length will be small. That means high enthalpy is required to break it. Thus, it becomes less reactive. Thus, it becomes less reactive. Whereas, in a case of CCl, the bond length is comparatively larger, so will be weaker. As a result, it will be reactive and will easily form chlorine-free radical. Got it? Next thing. Chlorine-free radical in the stratosphere decompose ozone layer. So, chlorine-free radical, what happens when combined with ozone, forms ClO free radical plus oxygen. The ClO free radical further combines with a nascent oxygen, form chlorine-free radical and oxygen gas. These are the 2 reactions which shows the depletion of ozone layer. Yes, very much important. Please learn it and practice it. The question can be added to it is, the chlorine is able to deplete oxygen, but not the ozone. Reason behind that, In the case of oxygen, it's having a strong double bond character. The bond length is smaller. As a result, it becomes unreactive, or I should say inert, to the chlorine free radical because it is not having the sufficient amount of energy so that it can break the oxygen in the stratosphere. So chlorine in the stratosphere becomes chemically inert for oxygen molecule. Yeah, it's very easy topic. It's way cakewalk for every one of you, I believe. Just need to practice the arrow again and again, and we are saying on the same thing. When it comes to the mechanism, what needs to be keep in mind is the arrow that you are moving out, how you are proceeding out with the reactions. Yeah. In the next video, sorry, we will be meeting out and we'll do the electrophilic addition reactions, oxidation reactions, and reduction reactions. And I will make a separate video for benzene and the nitration of benzene. So I hope this free radical mechanism and the type of questions that can be asked from this question, from this context, is being clear to you. If you have still any questions, any queries, you are please most welcome to share that in the chat box, and I will be open to that particular queries. For sure we'll answer that. We'll go out with the comments of each and every one and we'll answer each and every questions. So stay tuned, keep watching, keep preparing well, and have a good day. And don't forget to subscribe that button, the channel, so that you are updated with what is coming next. Stay tuned and have a good day. Bye-bye.